Hi everyone, welcome back to StudyChop. In today's video we are going to be adding and subtracting vectors and giving a basic introduction on what vectors are. Now, if you have come looking for how to add and subtract vectors, it is actually a lot simpler than you think. And we'll just go through these 8 questions here, and then you should be good when adding and subtracting vectors. So for question A, minus p. Well, we all know that when you put a negative sign in front of a vector, the magnitude stays the same, but the direction is flipped. So minus p is the arrow here, it's just flipped to the other side, so it goes in that direction, but the magnitude stays the same. Hence, there is, out of these options here, which one matches minus p? It's just the f vector. So we would write f, and then don't forget this squiggly line. Minus 2r. 2r is this one. And so 2r means that one vector x, is equal to 2r. That means vector x is twice the magnitude of r, and it's going the opposite direction to r, which means that the arrow must be facing in a northeasterly direction. And it must be double the magnitude. So, out of our options on the right hand side, which vectors are facing northeast and have double the magnitude of basically 1? Well, the answer is only D, this vector here. So we would write D. Now, adding and subtracting vectors. Question C. When adding vectors, we must make sure that the direction stays the same and that the magnitude stays the same. So for instance, P plus Q. But we can also remember that you can shift the vectors up and down. So you can shift vector P like that, or you can shift it like that. But the magnitude and direction has to stay the same. And when adding vectors, you must make sure that it goes head to tail and then head to tail, like that. Okay, so P plus Q. We need to shift P or Q so that they are head to tail and head to tail, so that the bottom of Q, if we do Q plus P, must meet the tail of P. So the head of Q must meet the tail of P, or the tail of P must meet the head of Q, but for that to happen, it would go off our chart. So, Q plus P. We're going to shift P 1, 2, 3, 4 units down and 1 unit to the right, so that we get a graph like that. But remember, P, the direction of P is staying the same and the magnitude is the same. We've just shifted it across our coordinate plane, and the vector that is Q plus P is just this line making up a triangle. But remember, the direction of the vector is always joins to the tip here. It doesn't follow the head to tail rule like this vector would. It doesn't follow like that. It meets at the head. So if our vector is going this direction and has a gradient of -2 and has a rise of -2 and a run of 3, our only option is H here. So C would be H. Now Q plus R. Using the same tactic, Q of not changing the magnitude, just shifting it, Q plus R. So for this one, we only need to shift Q down by 1 unit. Make sure the magnitude stays the same, and it's head to tail, and then, tail to head, and then tail to head. So we have that rule fixed, and then going in the opposite direction that the head to tail to head is going. So it's just a straight line down with about 1, 2, 3, 4. So 1, 2, 3, 4 units. So our answer must be B. Now, subtracting vectors. Whenever there's a minus sign in front of the vector, remember that just means that we're just swapping the arrow around and it's facing the other direction. So when we have minus q and minus r, I'm just going to swap the arrows around, and we want to make sure that they are going head to tail, or tail to head, or head to tail, or head to tail. Now, how do we do this? Well, we can shift our R1 up so that it is going like this, head to tail, head to tail. Yep. So if we're going tail to head, that means the bottom, the tail to head. So that means the part connecting to the bottom of P must be a tail. So we can put shift R up, however many units that is, so that but remember, keep the magnitude the same so that it is head to tail to head, and then we just find that the vector is just this line here. Oh, but it's going in the opposite direction, so it's just like that, and we find that our vector is C. Okay, minus q plus r. So the minus just means that we're flipping the arrow of q, and plus r. So that means r stays the same. Remember, we have to go tail to head, and that means that we can just shift r over here. So we move r one to the left and then up, so that it is tail to head. And remember that the vector is going in the opposite direction, so it's just like that. And that means our gradient is just 1 because the rise and the run are the same. So that means our answer is A. Now, adding 3 vectors. Remember, head to tail, or head to tail, or tail to head, tail to head, tail to head. Okay, so since there's no negative signs, all of our vectors here remain the same, and we just have to find a specific combination. Now I'm going to add q to p, since tail to head, so p's tail must connect to, q's tail must connect to p's head, and it's just going to be like this. So now q is done, and r, the head of q must meet with the tail of r, so it's just like that. And then our connecting vector going in the opposite direction is like that, and it has a rise of -3 and a run of 2, hence our vector is vector E. Now, H, P minus Q plus R. So we are only changing the direction of Q because of the negative sign, and we need to find a combination where it's tail to head, tail to head, tail to head. Right. So we have, what do we have here? We can move Q up 1 unit. So it's tail to head. Tail to head, and then tail to head, and then we can move the R vector all the way up here so that it is going like that, and hence I'll draw that a bit better. So our R1 is just going like that because it has a gradient of 1, and hence our vector going in the opposite direction that the head to tail is going in is just a straight line, and it is G. Thanks.